trail of ones. So what we basically do in trail of ones, is like this, that there will be one string, okay, there will be one numbers, and that number is 2, suppose, and we have to generate the strings of length 2 and which have consecutive ones. Okay, so I will explain the problem over here. Say for example, we are taking over here, say for example, just a second, yeah. Say for example, n equals to 2. Okay, so in this case, n equals to 2, what are the possibilities of strings we can generate? Using zeros, using zeros and ones. Okay, so the possibilities of strings which can be created using zeros and ones are 0 and 1, 1 and 0, 1 1, 0 0. Is there any other possibilities? No. So in this particular possibility, output will be, if somebody asks what will be the output on of, so the output will be 1 and 1. Okay, so let's check the example. So you can see the output is 1. So we have to take the count of this value. So we have to take the count of this value as number of times it occurs. So count this values occurrence. So if this values occurrence is greater than 1, it has to be always greater than 1. Say for example, let's take an example of n equals to 3. So how many 3-digit strings we can form with all these possible combinations? So the combination can be 0 0 0, 0 1 0, then 0 1 1, and then 1 0 1. What else? 1 1 1 and 1 1 0. So 1 2 3 4 5 6 possible combinations. So out of this, consecutive 2s are appearing in how many occurrences? So you can see over here, over here, over here. So the output is most probably 3. So for this, the output is 3. So there can be 8 strings. What else can be the possibilities of strings? So 0, in position of 0 I have placed 1. Okay, in it can be 0 1 0 is done. Let me check what are the other possibilities. 0 0 0 0 1, 0 0. Okay, so I've missed 0 0 1, 0 0 1, 0 0 0 0 1, and 0 1 1, 0 1 1 is also done. Okay, 0 1 0 is done, 0 1 0 is done. Yes, 100. So 100 is missing, the most important number. So over here you can see total number of times it is occurring. So count greater than 1 is satisfied, and the count value is 3. So 3 will be our output. So how this is going to work? So we have to think of, first you have to take the modulus value, which is 10 to the power of 9 plus 7, which is given in the question. Over here you can see it is given in the question that it has to be 10 to the power 9 plus 7. Now, as you can see, one base case. So for every possibility of whenever the value of n is 2, you can see the output is becoming, count is becoming 1. So we can develop the algorithm like this. Say I'm going to develop the algorithm. So I will write it over here, algorithm, and under this algorithm I will first check if the value of n equals to 2, then what I will return? I will return simply 1, because there is only one possible combination. What else can be checked? So if the value of n is 1, then I have to start the loop. I have to start another loop. So the loop will start from I equals to 3, because 2 values are already checked. For 2 values it is 1. Okay. So similarly, it is I equals to 3 is done. Then I have to check I less than equals to n. Then I have to do I plus plus. Okay. In this, I have to do the calculation of Fibonacci. So suppose there are 2 values. Okay. Suppose there are 2 values, a equals to 0, b equals to 0. Okay. And you know that in Fibonacci what happens is the first is 0. So you can take the second element as 1. There is an answer which has 1. So why answer is 1? Because for n value as 2, it will always return 1. So one answer is already stored. So we are assuming the answer to be 1 predefined. So once this is done, we are going to do the sum of the previous 2 values, counts. previous two counts. So total number of count, how do you determine the total number of count? We determine the total number of count by the addition of the previous two values, okay, like this. Similarly, after that we are going to swap it, a equals to b, b equals to c, okay, and what we have to do is we have to take the answer. So answer is answer plus c. So why we are doing answer plus c? So answer is taking the count plus equals to c, and whatever modulus things you are seeing, that modulus value has to be added over here, because modulus of 10 to the power 9 plus 7 will be there, because say for example the size of the string n equals to, over here they have given an example as n equals to 5. So n equals to 5 have 19 such possible combinations. So how is n equals to 5 defined? So 0 0 0 0 3 4 1. So this is 1. Like this there can be a combination like 0 0 0 1 1. So this is also this is a correct combination. Similarly, there can be 1 1 1 1. So there's also a right combination. So why these are correct combinations? These all are correct combinations because they have consecutive ones or ones which are repeating after each other. So in a problem statement like this, you have to think of the broader perspective. So say for example, I have the first value is n equals to 2, right? So then after the value of n equals to 2, what can be the n value of 3? So the value of 3 can be like this. Then there is a value of 4. Then there is a value of 5. So let's do the count of each. So for 2, we know the count is, what is the count for 2? The count is 1, okay. So what is the count for 3? So we have checked the count for 3 over here. We have checked the count of 3 over here is 3. The count of 3 over here is 3. We have checked the count of 3 over here is 3. Similarly, if there is a value of 4 and then there is a value of 5 as 19. So what basically for 3 you can check, it is the sum of the previous count, which is 1, plus the present count of 2. So you can write it as, what you can write it as, like you can write it as total number of count as 3. But total number of count is not dependent on the like a Fibonacci series. So what is a Fibonacci series? 0 1 1 3 5, okay, 8 9 11. So this is like the Fibonacci series. So if this Fibonacci series is like the sum of 5 plus 3 is 8 and 1 plus 0 is 2 is 3. So like that. So the Fibonacci series is like this, but this is not a Fibonacci series. This is the count. We have to take the count of the places where one comes after another, where one is there repeating itself. So this was about today's problem statement. So this is a very simple problem. First you have to take for n equals to 2, we have to return 1, and n 0 as given over here, and then we have to do the summation. And everywhere we have to do modulus mod value, because it has already given in the question that we have to return the answer after modulo of 10 to the power of 9 plus 7. So we are going to quickly submit the solution. So this was today's problem statement. I hope you liked it. Thank you.